Topic 1. The first topic reference from Topic Understanding and Servicing Alarm Systems. Third edition is the fundamentals of electricity, circuits, and components. This topic covers the basic concepts and principles that are essential for understanding how alarm systems work. It includes the following subtopics: the structure and properties of atoms, electrons, and electric charges, and how they interact with each other through electric forces and fields. The definition and measurement of electric potential, voltage, current, resistance, power, and energy, and how they are related by Ohm's law and Kirchhoff's laws. The types and characteristics of common electrical components such as resistors, capacitors, inductors, diodes, transistors, and integrated circuits, and how they are used to build simple circuits and devices. The concepts and applications of alternating current (OECT) and direct current (DC), and how they are converted and regulated by transformers, rectifiers, filters, and voltage regulators. The methods and tools for testing and troubleshooting electrical circuits and components, such as multimeters, oscilloscopes, logic probes, and continuity testers. Topic 2. The second topic reference from Understanding and Servicing Alarm Systems, third edition, is the types and functions of various detection devices. This topic covers the different kinds of devices that are used to detect the presence of fire, smoke, heat, gas, motion, intrusion, or other conditions that may indicate an emergency situation. It includes the following subtopics: magnetic contacts. These are devices that consist of two parts, a magnet and a switch. They are usually installed on doors, windows, or other openings that can be opened or closed. When the magnet and the switch are in contact, the circuit is closed. When the magnet and the switch are separated, the circuit is opened. This change in the circuit status can trigger an alarm signal to indicate an unauthorized entry or exit. Motion sensors. These are devices that detect movement in a specific area or zone. They can use different technologies, such as passive infrared (AR), ultrasonic microwave, or dual technology, a combination of two or more technologies. They are often used to protect large spaces or areas where other detection devices may not be effective. Glass break detectors. These are devices that sense the sound or vibration of breaking glass. They can use acoustic or shock sensors to detect the frequency or intensity of the glass breakage. They are usually installed near windows or glass doors that may be vulnerable to forced entry. Smoke detectors. These are devices that detect the presence of smoke particles in the air. They can use different methods, such as ionization, photoelectric, or optical beam. They are designed to provide early warning of fire before it becomes too large or dangerous. Flame detectors. These are devices that detect the presence of flames by sensing their radiation or wavelength. They can use ultraviolet, UV, infrared, ERA, or visible light sensors to detect different types of fires. They are often used in high-risk areas where fast and accurate fire detection is critical. Combination detectors. These are devices that combine two or more detection methods in one unit. For example, a smoke and heat detector can use both photoelectric and fixed temperature sensors to provide more reliable fire detection. A motion and glass break detector can use both PIR and acoustic sensors to provide more comprehensive intrusion detection. Sprinkler water flow alarm initiating devices. These are devices that monitor the flow of water in a sprinkler system. They can use mechanical or electronic switches to detect when a sprinkler head is activated by a fire. They can also provide supervisory signals to indicate the status of the sprinkler system, such as low pressure, valve tampering, or pipe rupture. Topic 3. The methods and materials for wiring and connecting alarm devices, such as wire gauges, connectors, terminals, splices, soldering, and testing, are explained in detail in the book Understanding and Servicing Alarm Systems. 3rd edition. Here's a brief summary of some of the methods and materials that are covered in the book. Wire gauges. These are the standard sizes of wires that are used to connect alarm devices to the control panel or to each other. The wire gauge determines the current carrying capacity and the resistance of the wire. The higher the gauge number, the smaller the wire diameter, and the lower the current carrying capacity. The lower the gauge number, the larger the wire diameter, and the higher the current carrying capacity. The recommended wire gauge for alarm devices is 22 AWG, which can handle up to 0.92 amps of current tone. For smoke detectors and AC power to the control panel, 18 AWG or larger is required too. Connectors. These are the devices that are used to join 2 or more wires together. They can be classified into 2 types, mechanical connectors and solderless connectors. Mechanical connectors are metal devices that clamp or screw onto the wires, such as wire nuts, terminal blocks, or crimp connectors. Solderless connectors are plastic devices that snap or slide onto the wire, such as insulation displacement connectors, OIDCs, butt splice connectors, or quick splice connectors. 3. Terminals. These are the metal parts of a device that are used to connect wires to it. They can be either screw terminals or plug-in terminals. Screw terminals are metal screws that tighten onto the wires, such as those found on control panels, sirens, or transformers. Plug-in terminals are metal pins or sockets that fit into matching connectors, such as those found on sensors, keypads, or Modulus 3. Splices. These are the methods of joining 2 or more wires together without using connectors. They can be either soldered splices or twisted splices. Soldered splices are made by melting solder onto the wires, which creates a strong and permanent bond. Twisted splices are made by twisting the wires together, which creates a weak and temporary bond. 3. Soldering. This is the process of using a heated iron and metal alloy called solder to join wires or components together. Soldering creates a strong and reliable electrical connection that can withstand vibration, corrosion, and temperature changes. Soldering requires skill and practice to avoid damaging the wires or components or creating cold solder joints. 3. Testing. This is the process of checking the wiring and connections of alarm devices for proper operation and functionality. Testing can involve using different tools or devices such as multimeters, oscilloscopes, logic probes, continuity testers, tone generators, or signal analyzers. Testing can also involve using different methods or procedures such as voltage testing, current testing, resistance testing, continuity testing, polarity testing, loop resistance testing, signal strength testing, or signal format testing. 3. Topic 4. The features and operations of different types of alarm control panels, such as hardwired, wireless, hybrid, and microcomputerized systems, are explained in detail in the book Understanding and Servicing Alarm Systems, 3rd edition. Here is a brief summary of some of the types and features that are covered in the book. Hardwired systems. These are systems that use wires to connect the alarm control panel to the sensors, devices, and circuits. They are usually more reliable, secure, and durable than wireless systems, but they are also more difficult and costly to install and maintain. They are suitable for large or complex buildings that require a high level of protection. Wireless systems. These are systems that use radio signals to communicate between the alarm control panel and the sensors, devices, and circuits. They are usually more convenient, flexible, and easy to install and maintain than hardwired systems, but they are also more prone to interference, hacking, and battery issues. They are suitable for small or simple buildings that require a low level of protection. Hybrid systems. These are systems that combine both hardwired and wireless components to create a customized and versatile system. They can offer the best of both worlds by using wires for critical or high-risk areas and radio signals for non-critical or low-risk areas. They can also allow for easy expansion or modification of the system without replacing the entire System 12. Microcomputerized systems. These are systems that use microprocessors or microcontrollers to control and monitor the alarm system. They can offer more features, functions, and intelligence than conventional systems, such as programmability, self-testing, event logging, remote access, and integration with other systems. They can also use different types of communication methods, such as telephone lines, cellular networks, radio frequency, or Internet Protocol 134. Topic 5. The methods and standards of alarm reporting, such as telephone lines, cellular networks, radio frequency, Internet Protocol, and central station monitoring, are explained in detail in the book Understanding and Servicing Alarm Systems, 3rd edition. Here's a brief summary of some of the methods and standards that are covered in the book. Telephone lines. These are the most common and traditional method of alarm reporting. Use the Public Switch Telephone Network, PSTN, to transmit alarm signals from the alarm panel to the monitoring center. They can use different formats such as pulse dialing, touch tone dialing, or digital communicator. They can also use different protocols such as Contact ID, CIA, or 421. Cellular networks. These are wireless methods of alarm reporting that use cellular phone technology to transmit alarm signals. They can use different technologies such as GSM, CDMA, or LTE. They can also use different formats such as SMS, voice, or data. Radio frequency. These are wireless methods of alarm reporting that use radio waves to transmit alarm signals. They can use different frequencies such as VHF, EHF, or microwave. They can also use different modulation techniques such as amplitude modulation, AM, frequency modulation, FM, or phase modulation, private message showing. Internet Protocol. These are wired or wireless methods of alarm reporting that use Internet Protocol IP to transmit alarm signals. They can use different networks such as Local Area Network, LAN, Wide Area Network, WAN, or Virtual Private Network, VPN. They can also use different protocols such as TCP/IP, UDP/IP, or HTTP/PON. Central Station Monitoring. This is a service that provides 24/7 monitoring of alarm systems by trained operators who can verify and respond to alarm signals. They can use different methods of verification, such as audio verification, video verification, or cross-zoning. They can also use different methods of response, such as calling the premises, calling the authorities, or dispatching a guard to. Topic 6. The troubleshooting techniques and tools for diagnosing and repairing common alarm problems, such as ground faults, shorts, opens, false alarms, and communication failures, are explained in detail in the book Understanding and Servicing Alarm Systems, 3rd edition. Here's a brief summary of some of the techniques and tools that are covered in the book. Ground faults. These are faults that occur when a wire or a device in the alarm system comes into contact with a ground source, such as a metal conduit, a water pipe, or the earth. This can cause a low resistance path for the current to flow, which can affect the performance or operation of the alarm system. To troubleshoot ground faults, you can use a multimeter to measure the resistance between each wire and the ground. A low resistance value indicates a ground fault. You can also use a tone generator and a probe to trace the wires and locate the source of the fault. Shorts. These are faults that occur when two wires or devices in the alarm system come into contact with each other, creating a short circuit. This can cause a high current flow, which can damage the wires or devices or blow a fuse. To troubleshoot shorts, you can use a multimeter to measure the resistance or continuity between each wire or device. A zero or very low resistance value indicates a short. You can also use a tone generator and a probe to trace the wires and locate the source of the fault. Opens? These are faults that occur when there is a break or a gap in a wire or a device in the alarm system, creating an open circuit. This can cause a loss of current flow, which can prevent the alarm system from functioning properly. To troubleshoot opens, you can use a multimeter to measure the resistance or continuity between each wire or device. A very high or infinite resistance value indicates an open. You can also use a tone generator and a probe to trace the wires and locate the source of the fault. False alarms. These are alarms that are triggered by something other than an actual emergency situation, such as environmental factors, human errors, or faulty devices. False alarms can cause annoyance, inconvenience, or fines for the customers and reduce the credibility of the alarm system. To troubleshoot false alarms, you can use various methods to verify and identify the cause of the alarm, such as audio verification, video verification, cross-zoning, event logs, or sensor testing. Communication failures? These are failures that occur when the alarm system cannot communicate with the monitoring center or authorities due to various reasons, such as line cuts, interference, network congestion, or equipment malfunction. Communication failures can compromise the security and safety of the customers and prevent timely response to emergency situations. To troubleshoot communication failures, you can use various methods to test and analyze the communication signals and formats, such as signal strength meters, signal analyzers, line testers, protocol analyzers, or loopback testers.